All right. Greetings, everyone. Thank you for joining us at Exchanging Ideas 52 Global 5G Evolution. I'm Kanishwaran Govindasamy, the founder of Global 5G Evolution. A warm welcome to all the speakers around the globe. I really appreciate and grateful to all of you to join in this event. To the audience out there, please take a couple of seconds to click the subscribe button on our YouTube channel. Uh, and to the speakers, at the end of this session, I would really appreciate as many as of you yeah, if to be involved in the Q&A, where some of these questions that we will arise in terms of are telcos slowly dying, or is the spectrum race is dead? And what are the emerging 5G use cases or any use cases that have the potential to disrupt the telecom mobile network operators? Um, let's have a very open chat. Any of the speakers have some great ideas in your experience. Please feel free to discuss this at the end of this conference. And without due delay, my presentation topic titled as a closer look at 5G Advanced Release 18. There are two main goals for Release 18. Number one is strengthening the 5G system foundation, and this involves enhancing existing technologies and introducing new ones to improve network performance, capacity, and efficiency. Number two is proliferating 5G to all devices and use cases, and this aims to expand 5G reach beyond traditional smartphones to encompass a wider range of devices and applications. Not forgetting mobile broadband evolution, which improves the download and upload speeds, expanding coverage and exchanging user experience. Now, if we zoom, the advanced download and upload MIMO, it enhances the antenna technology for better data transmission, enhance mobility, improving network performance for user on the move, boundless extended reality, supporting immersive experiences like AR, VR, XR, RedCap evolution, developing a new category of devices with lower power consumption and cost for wider adoption, evolve duplexing, optimizing spectrum usage for better network efficiency, expanded site link, enabling direct communication between devices without relying on core network, expanded positioning, improving location accuracy for various applications, um, AI, ML driven designs, leveraging AI and ML for network optimization, green networks and devices, promoting energy efficiency, reducing environmental impact, drones and satellites, supporting use cases like drone delivery and satellite-based services. And lastly is multicast and other enhancements. It improves the network efficiency for broadcasting content to multiple devices simultaneously. Now, if we look at MIMO, is the key technology that enhances data transmission efficiency by using the multiple antennas at both TX and RX, and the improvement for both uplink device to network and downlink network to device transmissions. Now, driving additional 5G uplink coverage enhancements is the major discussion this year, with random access enhancements, improving efficiency of initial connections between devices and the network, especially in millimeter wave spectrum. Not forgetting power domain enhancements, increasing maximum power limit for devices while reducing peak of average power ratio through spectrum shaping. And also dynamic waveform switching enhancement, improving spectral efficiency by dynamically switching between different waveform types. Uh, the improving of 5G device mobility management, there are three main areas. One, layer 1/2 base intercell mobility, which enhance the cell selection and handover process between base station for smarter transitions. Number two is NRDC with selective activation for cell groups, optimizing the reuse of multiple cell groups in dual connectivity scenarios for better performance. And the millimeter wave enhancements It's quite critical, improving handover and setup procedures in millimeter wave frequency bands. Now, the other area is the cost-efficient expansion of 5G coverage and capacity. It focuses on two main approaches to enhance the 5G coverage and capacity. One is the mobile IAB, where this involves using mobile units such as those mounted on vehicles to provide access and backhaul connectivity. Number two is the network control repeaters, NCR, and these are the fixed repeaters managed by the network to extend the coverage. Now, if you look this energy efficiency in 5G networks, number one is the low power mode, optimizing device network behavior during the inactive periods to reduce the energy consumption. Number two is power adaptation, adjusting power leads based on network condition and device requirements to minimize the energy use. And number three is the spatial adaptation, optimize antenna configurations and beamforming to reduce the energy consumption while maintaining the performance. There are also three main approaches to achieve a greener system. Immediate focus is by implementing device-only techniques to conserve the energy at device level. Secondly, they optimize the network energy efficiency by targeting energy savings in both RAN, particularly base stations, core network, including the data centers, and this involves optimized network infrastructure, traffic management, and cooling systems. Also explore and end-to-end energy saving opportunities as well, because it identifies the opportunities for energy reduction through foundational air interface technologies, and this includes optimizing traffic load management and leveraging the device feedback to improve energy efficiency. So in terms of the release 18 related to low power wake up signal receiver, the technology is designed to reduce the power consumption in power sensitive and small form factor devices. The laying the foundation of full duplex communication is very much involved in the release 18 study that it evaluates the potential of non-overlapping subband full duplexes. And then the applications of AI to address complex challenges in wireless communications that conveys the idea that by combining the deep wireless domain knowledge with AI capabilities, it's possible to develop innovative solutions for the intricate problems faced in wireless communications. This is an overview of the role of AI and ML in the evolution of the next gen RAN with release 18. And the core objective is to leverage the AI and the machine learning to enhance the performance and effective of the 5G air interface. Also to develop a robust AI ML to enhance the performance and the efficiency of the 5G air interface. And the potential benefit is improving the spectral efficiency, the enhance the network capacity, a lower energy consumption, reduce latency, and enhance the user experience. Last but not least, these are the two main areas that I want to stress here. On the left-hand side is the improving of existing 5G capabilities. It's enhancing the existing technologies that like dynamic spectrum sharing, the multi-carrier support and multi-SIM to boost the performance and efficiency. And on the right-hand side, it introduced the new features like adding new functionalities such as small data TX, improve quality of experience, and timing resiliency to expand the 5G capabilities. So I think that's all the presentation from my side. I think I've covered within the 10 minutes time allocation. So without due delay, let me introduce our next speaker, Juan Luis Tolosa Martinez from Madrid, Spain, to present the digital sustainability. Just 1 second, let me stop share. Over to you, Juan.
Okay. Thank you so much, Ganesh. I think that you can see my screen right now.
Yes, sir.
Okay. First of all, thank you so much for inviting me to be part of this panel. It's fantastic for me. My name is Juan Luis Tolosa. I'm the CEO of a company called BNG, and my background is is telco. I spent 15 years in the telco space, working for MNOs, for OEMs, and also for global system integrators. Okay, and a couple of years ago, I launched a startup that is called BNG, with the focus on how can bring something different to technology, that is to have a sustainable approach in technology. Okay, well, I would like to start with the same question that I make to my customers, and it is how many tech companies can accurately report the carbon footprint of their solution or the energy consumption. 99.9 of the times, no answers. And there is a reason for that, because we have this dual nature of technology. Okay, and that is something that we are putting the focus on the indirect impact. Okay, when we speak about AI, about 5G, we think about the benefit that will bring us in the future. Okay, but nobody is taking care about what happened the day zero. When you run an AI model, you start consuming energy and then releasing carbon to the atmosphere. Then that is impact. I am really a believer of the indirect impact, okay? But of course, we need to put the focus on make the technology solutions sustainable by design, okay? We were speaking about the efficiency in the 5G standardization, and that is true. But we need to take into account that we are boosting all this standardization with AI. We need to analyze not only the return of investment, we need to analyze the return on energy efficiency, the return on sustainability. And that is where we put the focus, okay? It is not possible to make a green IT or some buzzwords that are running over there, but we need to make digital as green as possible, okay? And that is our purpose. And that is what the market says. Is all the green IT aspects are growing a lot, exponentially, and that is because when you speak with a CEO, there are two topics on the table: digital transformation and sustainability. But they don't see each other, you know. And digital world is becoming to be one of the biggest energy consumption factors in the world. Okay, there you can find that we will move from 7% to the double, 7% of to the double in 2030, and this is something that we need to take into account when we launch our strategy. In the telcos aspect, is the same. MNOs have changed a lot. MNOs are one of the biggest consumer of technology, of AI, and so on. Then this kind of aspects need to be, they need to take it into account, okay? And this is not something that is said by me. Now there are a lot of regulation trying to short up that. Okay, we have a new ISO launched in May this year in order to analyze, to standardize the measurement of software carbon intensity. And the things are moving very, very quickly, and we need to be ready. That's the point. Here, just to highlight, there are a lot of documents speaking about this topic. This one is a very, very good document, the Digital Economy Report, okay? And some highlights, and it's we have a measurement challenge. Nowadays, we make everything, we are speaking about AI, but we analyze the carbon footprint based on empiric things, based on estimation. Let's measure. Okay, let's be more science. Of course, environmental footprint impact is more than energy. We have a challenge with the water also, and that is something that nobody is putting the focus on. Okay, we are saying that, for example, 5G, and that is true, is much more efficient in a gigabit kilowatts per gigabit, but the traffic based on the use cases are growing exponentially, then the total energy consuming consumption is growing. We need to take into account that. Also, we need to take into account the back swapping strategies. It's okay now. I will change all my infrastructure for one more efficient. Okay, let's wait. Let's analyze, because we need to have in our mind that optimization is fast. Okay, and also to put the focus on the right place. We're speaking about mineral extraction and so on, but the reality is that 70% of the energy consumption is in the run phase, okay? And we need to put the focus there. Okay, this is what is down today. Today we have a ESG reporting focus. We estimate things and we dedicate our time in order to get some carbon credits, to implement green energy infrastructure and so on. This is what is happening today. What can be done? And what is our approach is, okay, let's spend our time in order to analyze the resource consumption with real measurements, and not only in the infrastructure, physical infrastructure aspect like computing, servers, and network. For example, network in a data centers only means around 3% of the total energy consumption. The biggest part is in the servers. But what is more important, who is consuming the energy is not the server, it's the software running inside. And that is critical for us. That is critical. We need to be able to measure how is consuming energy any small piece of software. After that, okay, it's good to find carbon credit and so on. But if we have real measurements, we will be able to try to optimize this consumption. And that is critical for us, okay? And after that, of course, let's try to neutralize this CO2 equivalent generated by your networks, by your data centers, by your software solutions, okay? This is our approach. We have developed our own technology based on some existing protocols in order to be able to analyze the energy consumption for any piece of software, okay? On top of that, we are analyzing how the energy is generated in any place in the world in order to analyze what place is better regarding to the carbon footprint, okay? Based on the energy pool generation. But our first purpose, our first goal is the transparency. Let's show the rest, what is happening. Let's measure real metrics, because if we do that, we can optimize it, okay? On top of that, of course, we need to be compliant with regulation, and we need to prepare all the data needed in order to be certified, in order to be compliant with regulation, okay? But let's make transparent, let's be efficient, and after that, let's try to certify. And that's some screenshots for platform, okay, where we are able to analyze the carbon footprint in the digital asset at company level, at physical asset level, and also at software level, okay? And I think that that's all from my side. And there you have my coordinates, my email and phone number. And if you have any doubts or any discussion regarding to this topic, I'm fully open to do it. Thank you so much.
That was brilliant, fantastic, Joan. Thank you so much. Appreciate that. Now, moving on to the next speaker, let me introduce Lim Jiun K, or to be named as JK, from Kuala Lumpur, Malaysia, to present on 5G power of network APIs. Over to you, JK.
All right, thank you, Kanesh. Give me a second. Hopefully the screen is going up soon. Everything is all right there? It's doing
Yes.
well. All right, great. Thank you. I mean, once again, thank you very much, Ganesh, for inviting me on this session. We met about 2 weeks ago on relatively the same topic, we were both in this GSMA event talking about network API, and I was a panelist there, and that's where I get to know Ganesh, and he extended the invite to me. Yes, like what Ganesh briefly introduced. Yes, my name is JK. I'm actually the head of operating partnership for Infobip in APAC, Asia Pacific, and currently based in Kuala Lumpur, somewhere near to Ganesh, right? So, and today, actually, Infobip is actually a global leader in messaging community or messaging, providing messaging services to the enterprise, bridging the gap between the brands and also the mobile users. So we are actually, let's say, not just on the messaging side of the business, but also we have platforms that are global leader in CPaaS space and even in our SaaS as well. And together we have been, let's say, working closely with the telco for many, many years. Because we started off from, as mentioned, messaging, right? So which means that SMS is part of the thing that we are working on closely, and that's where we actually work closely with the telco. From there, we actually extended our collaboration from SMS toward the telco API as well. So let me start off with introducing or showing, indicating one of these examples that that actually managed to catch quite an attention from the market as well. So talking about APIs on this 5G as well, network APIs. So there's one thing which is, let's say, now starting to actually being exposed by the telco, which is the quality on demand, or actually QoD. So in this case, this is one example where the QoD API can be well utilized in the segment or the verticals of media and entertainment. So this is where we're talking about events or concerts or even stadium experience. So usually, I believe, all of you who are concert goers or who attend a lot of crowded sports events or even crowded conferences, you know that or you will be able to experience that your connectivity on your mobile somewhat, let's say, affected due to the congestion that happens. And through this QoD, that the telco can actually expose on API, allowing the, let's say, the application or let's say the brands or even the companies to actually leverage on this and trigger for this API in order to actually provide a user with better experience through example on the 5G network slicing. So in this case, the user will be able to actually ensure their quality or QoF in this case during that particular period. While let's say network is being congested, but because of that, certain users who actually has it enabled will be able to actually access the network. Thus, in this case, they are still able to actually utilize it for example communications, or example where people are more going the concerts goer today, they like to actually take live video and then post it on their TikTok or even the social media. So they can still continue to do that. And this actually not just improve the experience of the users, but on the other hand, telco is able to actually monetize this for their ROI on the 5G networks, which let's say totally today, it's not just about increasing the speed of 5G, but in this case, improve the experience and on the same time, able to actually get some value out of it. And that drives me to talk about how this actually come into the picture. So telco, they have been exposing APIs for many years, even way before this topic of open gateway or CAMARA. And the thing here is that all these years, it's very fragmented. The telco, every one of them, they have different sets of API. They're exposing different sets of APIs that it's made available, and it's very hard for the brands or even company like us who aggregates all these APIs to be able to provide to the enterprise. Take an example. Some countries, they let's say two telcos. one telco is exposing ABC APIs, while the other telco is exposing CDE APIs. So the only common APIs that available across both are C API in this case. So that's the only API that a consumer, or let's say a brand, can actually utilize. While the rest, yes, they can use, but the thing is that they will be limited to the coverage, which is actually one of the factors whether the brands willing to actually pursue on using such services. So this is where the drive, or let's say the APIs has not been really, let's say, well adopted in the market. And that's where last year, GSMA actually launched this Open Gateway or CAMARA initiative during MWC Barcelona. And that's where the whole thing kind of drive it because of standardization through it. So there is a set of standardized APIs that the telco would be exposing, and that helps to drive this adoption, as well as simplify how the telco can actually expose what they should be providing in terms of the API set. And of course, company like us will be able to actually leverage on that. And of course, we do work with a huge sets of, let's say, a developer community, and that's where we can actually bring the community together and bring them closer to the telco. And of course, we do have our sets of SaaS solutions that we can actually utilize on top of all these solutions to actually improve or improve the experience, and also provide a better or more secure digital environment for the mobile users. And then through these APIs, which means that it helps the brands to quicker to actually adapt to it. And of course, telco can actually faster to the market. And let's look into the overview of network API. As what mentioned earlier on, so it was started last year during MWC Barcelona. So they are actually, at this point of time, they are actually more than 57 telcos signed up already, but it enables to link to more than 240 telcos, because some they are group level, and then some they are actually the leaders in the country, and they are the one that actually bring the telcos in each of these countries together in exposing the same set of APIs. And then also through this initiative, there are more than 100 CAMARA APIs that has been defined. But then in the market today, I think there are 17 that has been exposed to the market by the telco. And of course, this is actually like what I mentioned earlier on. It's a part of helping the telco to grow the revenue from that. And we can actually, and there is these studies that actually shows that the trajectory of increase where the revenue will hit $300 billion by year 2030. So talking about all these APIs, of course, we need to actually able to implement into different verticals and the use case that are relevant to them in order to actually drive the usage in the market. So in terms of the likes of banking, financial, and insurance, BFSI industry or verticals, definitely we are talking about all these APIs to help them better protect the bank account users, where the fraudulent digital frauds or all these digital scams are so frequent nowadays. So the likes of example, SIM swap, device location, number verify. These are some of the APIs that can be used by the BFSI vertical. And then on the other thing, transportation, logistic, of course, quality on demand, device location are something that definitely usable by them. In terms of retail and e-commerce, number verify, the device location, and of course, like the media or entertainment sector, quality on demand plus the device location is something that definitely a good use case can be created from there. So we'll just run through some brief use cases. Like the first one here is actually number verify, and for the BFSI sector. So in this case here, we can see that the conventional method, maybe all of us are aware that things are actually validated through SMS OTP. But through this number verify, it's actually seamless behind, where the application will actually check with the telco through the API set, and if validated, then allow the users to actually log in without the need to actually wait for the OTP. Right. The next is actually to prevent or detect there are potential SIM swap where the account might have been taken over by someone else and then potentially withdraw all the money. So in this case, when there is a new registration on the application, immediately behind the scene, validation can be done to ensure that, okay, if this user has lately changed the SIM card, if yes, then to flag it so that the bank can actually do the necessary to validate if the user is indeed the intended user. So to prevent another person to actually steal the or access the account in that case. Because once your SIM card has been stolen, immediately once you register, all the OTP will reach to that person who actually stole that SIM card. In this case, the account would be definitely taken over, and all the money in the bank would then be stolen in this case. Next, of course, is more sophisticated one, which is actually device location. Because when during example transactions such as ATM cash withdrawal, paying on the post terminal, that's where during the transaction, the bank can actually trigger for validation of the device location, because usually you will have your phone near to you when you're doing this transaction. And that's where the validation can happen to ensure that, okay, indeed you are the one that is actually doing this transaction. If let's say there is some negative response, then immediately the bank can actually stop that transaction to prevent it from continuing. And here are some of the numbers of the frauds that are happening in the region, especially in APAC, which shows that indeed the fraudulent activity or the activities that happen is actually concerning, and it's important for the BFSI sector or this fintech sector to actually look into such solutions to actually improve the security and build confidence for the users in the digital space. And talking about transportation and logistics, just now we mentioned about QOD, right? So similarly, on-demand application, example, ride sharing, especially in a congested area, you might not be able to actually trigger because of the data congest. You can't actually trigger to actually use your application to actually order for ride, especially after a concert or after an event. So in this case, through QOD, then that's where at least you get the network, the access to the network, and then able to actually request or actually order a ride in that case. And talking and riding on top of device location on the media as well is that whenever people that actually let's say come into an area, let's say example a stadium, when they reach to the stadium, then because of the device location API, the let's say example a football club, the football club can then actually push some personalized content to the user once they actually reach into the area. So this is to able to differentiate, okay, example, some premium users or fans who actually pay for some sort of premium, they will be able to get some personalized content whenever they actually going for a match day or even concerts where you actually go there earlier. And in this case, you're able to actually get hold of the experience way before the concert starts. And just briefly about what set Infobip apart is that, as what I was actually mentioning earlier on, we are actually a global leader in this space. So our platform is actually recognized by Gartner, Juniper, IDC, and then on the other hand, we work quite a bit on the API side as well. We have our developer tribe as well. We call it Startup Tribe, where we actually bring all the developer community together. And we have been pushing quite a bit on this network API with these developers as well. And on the other hand, we work closely with telco globally, and then we have partnership with all the telcos in more than 70 countries. And of course, we create a go-to-market strategy together, and then we also provide security solutions for the telco. So we kind of know or talk the telco language in this case. All right. So some of information about how this network API is actually at the core of our platform, where actually the experience that we have, the relationship, and of course lately because of this network API, we are also partnering with Nokia, and both of us actually go into the telco to actually help telco to actually quicker in enabling this API to the market. Right. Just some briefing. Yep.
It's already more than 10 minutes.
All right. All right. Thank you for the 1 more minute here. All right. Yeah. So this is an example of our collaboration with the telco in Brazil. And of course, there is a short video to indicate what would be the difference between the experience of having the verified API versus the SMS, where using the APIs is quicker, while on the SMS, it takes, let's say, almost double the time, more than double the time, in order to actually complete that transaction. So this actually improves the user experience, right? So last but not least, for viewers here, you can actually take out your phone, scan the QR. There is videos that we actually published with Telefónica Brazil on this success story, which you can actually refer to. And thank you very much. And sorry for the overrun.
This is really brilliant, JK. Fantastic presentation. I'm really grateful to you. Appreciate that. Thank you so much. And let me introduce the next speaker, Professor Alexandros Apostolos from Kozani, Greece, to present on revisiting optical wireless communications for revolutionary applications in harsh environments. Over to you, Prof.
Thank you very much, Ganesh, first of all, for the meeting and also for introducing me. Let me share my screen. And let me introduce you to the world of optical wireless communications. Maybe reintroduce you in this world because it's an old story that came again to life. Before I start my presentation, let me tell you that I'm from my University of Western Macedonia, Department of Electrical and Computing Engineering, and I'm leading the team Sirius. In our team, we have 3 projects that is related to this topic. IRIDA, that is for in-body optical wireless communication, MINOAS, that is for terrestrial communication, and Avalon, a European defense fund that will start in January, that is for underwater optical wireless communication. So I try to make a presentation that will give you information for all of them. So my presentation has the following parts. First of all, we're going to see the next generation application scenario that we envision and where optical wireless communication will play a key role. What is new, why we're revisiting optical wireless communications, then some initial results, and finally, you're going to see our experimentation and validation approach. Now, when we talk for beyond 5G or 6G application, maybe something that comes in mind are in-body sensing, artificial AR, VR, holographic assistant, 3D printing, robotics, or even the Internet of Sensing. All of them, if we're going to look at them in a scale, means that we will have compact devices. We need to achieve high data rates that even exceed the 1 terabit per second limit. We are going to have reliability of more than 6 nines. And finally, a latency that is in the millisecond level. All of these requirements, we want even to achieve it in some very harsh propagation environments, like in-body and transdermal communications, for example, for retinal or cortical implants, where we need compactness, energy efficiency, and capabilities of wireless power transfer. We need to have a wireless fiber extender through free space optic terrestrial environments in order to have low cost and fast installation backhauling links that even reach terabit per second data rates. While for the indoor case, we envision visible light communications that has energy efficient, reliable, high data rate, can support mass productivity, provide availability for Industry 4 applications, and of course, they are user-friendly, since every user can be able to set its own infrastructure, has a low cost, and the installation time should be quite low. Moreover, we have free space optics for satellite communications, where the data rates should be in the orders of some terabits per second. The reliability should be high, and a key design parameter is also the transmission distance that should be tens of kilometers or even hundreds of kilometers. Now, let me go to Avalon. In Avalon, we look at the underwater optical wireless communication for several application scenarios, like protection of underwater critical infrastructure, underwater search and rescue mission, underwater unnamed vehicles coordination and communication, seaborder surveillance, deep sea exploration, Internet of Underwater Things, or even underwater command deployment with broadband connectivity. While we look again optical wireless communication, the reason comes from our friends in material science, actually. They have created some very interesting surfaces that we call meta-surfaces. These surfaces can go beyond the classical reflection transmission laws and beyond the conventional Snell law. That means the reflection angle can be different than the incident angle. As a result, if we connect those surfaces appropriately with some microcontrollers, we can create electromagnetic environments that can be coordinated by software. In other words, we can go beyond Shannon by coordinating even the electromagnetic environment. This is something that we can achieve also in optical links. Therefore, we visit the area of optical wireless communications based on this technology, and we see that we can achieve our goals in terms of data rate, reliability, and also transmission distance. Some initial results. The first result that I want to see you is from a publication that we have in IEEE journal IEEE journal on selected areas in communications. And it's about nano networking. Here you can see a human vein, and these are nano robots that can enable the vision of aim. In other words, shallow the surgery. The main problem that we have here is due to misalignment and the disorientation. And you can see in this figure that if we have a deterministic link that we have misalignment or disorientation, you can assume that here is the gateway, the receiver that you have outside the vein. Then you lost most of the reception energy. As a result, now when it's deterministic, you can see here that there is only a short area in which you can receive in a high SNR. And also you can see that the outage probability is minimized when the distance between the nanorobot and the gateway is specific. This is a very interesting area that can be achieved by terahertz of optical wireless communication due to the compactness that we can achieve in our devices there. We can have devices in millimeter wave. And it's the first challenge that we have, and the first direction that I would like to give in this presentation. The second one is using multiple optical arrays in a cascaded manner to create backhauling. In this case, you can see that you have some atmospheric phenomena like turbulence that can really create a huge negative impact in our links, and that as the number of optical configurable surfaces increases in a cascade manner, the reliability of the link decreases. A similar result can be seen here. This is about misalignment. Now, what is most important is this result, and to see that there is a very specific area in which we have specific values of misalignment and disorientation, in which our system is robust. Now, if we change our system and we put the optical RIS in a parallel manner, here you can see that you can have some diversity. As a result, the reliability of the system drastically increase. Finally, I would like to show you our experimental validation approach. It follows, as usual, 3 steps. The first one is based on a simulation. We have optical simulation, electromagnetic simulation, and stochastic phenomena simulations in our lab. Then we use in-lab verifications through our partners. And finally, real-world assessment in underwater equipment. As a next step, the challenges are understanding the harsh environmental electromagnetic characteristics, designing transceivers which allow low complexity optical beamforming, create powerful modulation SIMs, designing device discovery approaches, designing optical configurable intelligent surfaces with ultra-wideband functionalities, creating low complexity error correction code, and finally designing waveforms that boost energy efficiency. The work that we've done is right now supported by the project MINOAS, which is implemented in the framework of HFRI, called Basic Research Financial Horizon Support of All Science, under the National Recovery and Resilience Plans Greece 2.0, and funded by the European Union Next Generation EU. Thank you very much. I hope I didn't pass the 10 minutes time. The floor is back to you.
That was fantastic, Professor. Just one second. Yes, I really appreciate for your valuable slide. It was amazing. So now let me introduce to the next speaker, Dr. Victor Monson Baiza from Madrid, Spain, to present of the topic of artificial intelligence in non-terrestrial networks and satellite integrations in 5G. Over to you.
Okay. So let me share my screen. Okay, and now can you see my screen?
Yes.
Full. Okay, so good morning, everyone, and thank you for invitation and the introduction. And my name is Victor. I'm a payload architecture leader in by Satellion, and also I teach at University of Catalonia also. And in this presentation, the idea is to discuss the need for the importance of artificial intelligence in non-terrestrial network, like a non-terrestrial network, because the non-terrestrial network now, because the standard defined and this the space network, like a new member or new element in the 5G network. So the topic covered in this talk will include motivating this integration, the non-terrestrial network with in the 5G ecosystem, the method we have for integrating satellite into 5G, the necessity of the AI non-terrestrial network, how machine learning is incorporated in the satellite, what is the dilemma of the whether AI should be performed on board or on the ground, and the use cases that arise and the review of activity commissioned by different institutions at the moment. So the integrating non-terrestrial network into 5G is essential for energy global connectivity, particularly in remote and underserved areas. So non-terrestrial network support seamless communication across various environments, improving reliability and coverage. And the 3GPP standard plays a crucial role in the standardization disintegration, ensuring the interoperability and fostering innovation in the 5G ecosystem. By incorporating the NTN, 5G network can achieve greater resilience, expand their rates, and support a broader range of application, making it a vital advancement in modern telecommunication application or telecommunication market. So the network architecture for NTN comprises space, ground, and control management and using segment as for and shown in this figure. And is the space within the space segment, the new concept of the new space area. Consider a constellation that cover the three types of orbit, LEO, MEO, and GEO. And this new constellation will not only by multiplane, but also define a 3D constellation, the 3D architecture together. All orbits are designed together. And this is a new concept of NTN integration. So all elements, not just satellite, but also other aerial elements like craft, hubs, drones, can be considered as additional node in 5G network, which should be transparent to the user. So all of these elements, the integration of all of these elements is very big challenges to integrate in the 5G network, because the requirement of the space segment is not the same for the terrestrial network. Since 3GPP release 15, as the satellite and terrestrial networks have common objectives. So terrestrial networks expect to benefit from the wide coverage area of the satellite, which does not require deployment any terrestrial infrastructure to extend their coverage. This integration should bring more flexibility and efficiency in the network deployment and management. However, this integration is challenges as both network hubs specificities and mass coverage technologically. So a network operator can create end-to-end partitions and deploying services while guaranteeing the end-to-end KPIs. So in this table, the table summarizes the different modes of satellite integration into 5G networks. For example, direct access mode or indirect access mode as a related node, using gateway to connect other or smaller user equipment. So an integration as a transport as a transport network for backhaul link services. But the challenges in this integration, for example, when we consider in the satellite like a new member for 5G network, we have to support of the new radio waveform within the satellite. So the payload in the satellite has more problem with the non-linearity, for example, that base station in terrestrial network. I mean, this is more restrictive. For that, we need to define an adaptation for the waveform, for example. In the amplifier, the amplifier in the payload on board, the non-linearity, we have more problem than the amplifier, for example, in the terrestrial network. So parameter like a PAPR, the power peak rate, we have to adapt in a new waveform, in new requirement to be transparent for the user of the satellite. So it's not directly to use the new radio for 5G. We have to adapt the new radio to integrate the satellite. This is one example of the challenges. Other one, for example, is support for 3GPP and trusted access mechanism with the satellite network, or adaptation of the relay mechanism with the satellite terminal. So it's in this reference, for example, we have, I put this reference to including a different example with more detail. So exactly what is the need for artificial intelligence in NTN? So what is the objective for that? So the satellite communication ecosystem of the NTN is currently experiments a revolution in advanced technological solution and rising a new space area where lower orbits are emerging as a low latency alternative to conventional geo communication systems. So this new communication area brings fundamental operational challenges. Multiple SATCOM systems depend on the human expertise and manual intervention. But the human expertise or the human needed, this has main issues, main drawbacks. First, human involvement in system control activity leads to high operational expenditures and high latency. The second, the rapidly changing radio environment in the new space scenario claims for autonomously adaptive mechanisms that human intervention cannot offer. And third, the multitude of use cases and new scenario set by the satellite communication where the 5G is not possible. In the following years, this will produce data in large quantity. Thus, is beneficial and necessary to make satellite capable of automatically generated reliable action using the data produced. The artificial intelligence is entering satellite communication with the great promise to solve the previous issues. And intelligent system enable automatization of the process, specific input from satellite data, and translate them into actions. In addition, data-driven techniques might sustainably reduce to the OPEX. Given is a good moment to investigate or to research the artificial intelligence to reduce the latency in the synthesis depend on the data. So we have a lot of conditions to share or to look for a new application in the artificial intelligence in the non-terrestrial network. In this context, the advantage of the artificial intelligence, the satellite communication is progressing toward having all the ingredients, making machine learning like a part of artificial intelligence, making ML suitable for particular satellite-related use cases. In response to the increasing telecommunications market demand for flexibility and autonomy, the satellite payloads are being digitalized. For digital payloads are paving the way for the satellite with a highest level of flexibility to efficiently support new use cases, new applications. And the main function of the machine learning in new payload is the integration of satellite in 5G. But the main is the flexibility and the adaptability to autonomy, to have more autonomy in the different applications or different scenarios, different use cases from the satellite communication. So this payload include capability like onboard canalization, for example, interference mitigation techniques, digital beamforming, and different flexibility tasks. So other example, so with digital payload, satellite payload are not by their non-linearity effect and general impairment introduced by the hardware components I mentioned before for the new waveform. We can use machine learning to define this new radio or the adaptation of the new radio of 5G to integrate the satellite. Another example is the automatic dynamic resource allocation algorithm, are a key innovation to make satellite operator allocate bandwidth dynamically to design the areas and save resources. We can adapt more efficiency the radio resource, like a bandwidth, depend on the scenario, depend on the area. The main point of this contest is the question is where is the best place to deploy the machine learning system? On board, on the ground, directly to the satellite, on the ground station? What is the dilemma is where is the best place to put the algorithm, the machine learning algorithm? because the training data or big database for the training data can introduce more delay in the processing signal, or if we go to directly in onboard to reduce this latency or delay introduced by the satellite communication. So onboard training, for example, specifically refer to training a machine learning model directly on the device, on the platform itself. But this implied that the training process occurs where the data is being collected and is processed by the onboard systems, which can be crucial for application needing real-time decision-making, or and where communication delay to a central server are a concern. So what is the best configuration? This is a very the first point to solve when we want to integrate machine learning in the satellite. So when we talk about the integration of the satellite in the 5G network, the satellite translate a E not B in the E not B for 5G. The satellite is a new E not B, but a specific feature or specific requirement that the terrestrial node doesn't have. So in that case, for the user, this translation or this new requirement has to be transparent. So the machine learning, for example, or artificial intelligence in general, can help us to convert a satellite in a new it not be the transparently for the user. So in the reference I mentioned before, we collect with my colleagues in University of Luxembourg. We analyze different use cases for all layers from the OSID model. From the physical layer until the application layer, we identify different use cases like informing and flexible payload link adaptation to depend on the condition of the channel. We define adaptably different coding scheme or modulation schemes, and for the spectrum management, interference management, intelligent or routing in the intersatellite link, and for the application, for example, another user scheduling, the ground segment dimensioning more intelligent to determine what is the best position for the ground segment using machine learning algorithm. So in this reference, I recommend to read, because it's to understand where is the best option using machine learning in different use cases in the satellite network, or in general in non-terrestrial network. To finalize in this slide, to review this idea of why it's important to include artificial intelligence in the satellite communication to help us to integrate the satellite like a new member in 5G network. So I collect an overview of the more relevant activities carried out by private or public institutions worldwide on the deployment of machine learning in the SATCOM world. So first, on the one hand, some software testbed for node-geo constellation propose an experimentation software platform based on the software-defined network for validation of the new autonomous network slicing algorithm and their performance evaluation in the integrated terrestrial satellite systems. In the second place, the European Space Agency opened an AI-related call for SATCOM for the first time in 2019 to investigate the applicability of the artificial intelligence techniques in satellite communications. Several potential use cases were shortlisted during this project, and now a preliminary evaluation of the small number of them was carried out to provide guidelines for the future results. For example, the SATAI project, the SATAI's machine learning and artificial intelligence for satellite communication, or MILSAT machine learning for telecommunication 2, is the first 3 different proof of concept are developed for automatic interference detection. They propose flexible payload and traffic prevision. The third one, NASA has been actively investigating the cognitive radio framework in the satellite communication. And the European Commission, in his program, the Smart Network and Services Joint undertaking recently as well, the first batch of the project to facilitate and develop industrial leadership in Europe to integrate not only 5G, integrate the future 6G network also and services. Among the project, some of them including machine learning power optimization for the integrated 6G and non-terrestrial network. And finally, in the European Union Horizon 2020 Research and Innovation Program, already granting a few projects relating to the machine learning, like Atria or DINASAT.
Dr. Victor, you have taken more than 10 minutes.
Okay, yeah, I'll finalize. Finally, the conclusion is I want to present to show the important topic in this to integrate the non-terrestrial with 5G. So, and the artificial intelligence help us to integrate the satellite like a new member in the 5G network, and also to present different possibility use cases to study this possible integration. So thank you very much for your attention, and if you later do any question more, and we may contact here. Thank you.
Oh, this is fantastic, Dr. Victor. Very detailed, very informative. I really appreciate that. Now, let's move on to the next speaker. Let me introduce Marina Martinelli from Sao Paulo, Brazil, to present her research study in the strategic connectivity in 5G and 6G and remote surgery, the case of Germany. Over to you, Marina.
Thank you very much, Kaneshwaran. I will try to share my screen. Okay, just a second. So I'm here. No, not gracias yet. Okay, just a second. Can you see that?
Yes.
Okay, thank you very much. Thank you very much, Kaneshwaran. Thank you very much for Global 5G Evolution for this opportunity. I'd like to make some acknowledgements because my research was financed. I would like to say thank you to Universidade Estadual de Campinas, my university, Unicinos from Rio Grande do Sul, and Smartness, initiative of 5G and 6G laboratory from electrical and engineer faculty at Unicamp also. And we wrote a paper on strategic connectivity in 5G and 6G, a conjunction, because we see as similar things in remote surgery, the case of Germany. My collaborators, my colleagues in this article is Luiz Antônio Leite Francisco da Costa from Unicinos, from Department of Applied Computing, Alisson Mazzoni, postdoc at Department of Science and Technology Policy at Unicamp, Juliano Luiz Pereira Sanches, Unicamp also, as me, PhD candidate at the Department of Science and Technology Policy, and Professor Rafael Kunst, professor and researcher at Department of Applied Computing. Okay, so we wrote this paper on the Research Society and Development Journal. It is a different perspective of the other panelists. I'd like to congratulate my co-panelists because it's very interesting presentations. But in our case here, we are not thinking on the core of 5G or something like that. We are thinking on applications or industrial application of 5G in the case of remote surgery. Okay, so some highlights of the article. Remote and robotic surgery are vital for situations of distance necessity, okay, and viability of latency or ultra latency, a conjunction, okay, which means 10 to 1 milliseconds of time response in operations, which can save lives, okay. Mixed reality especially is possible through the metaverse, which in medical domain revenue is expected to reach 140 billion by 2027. 6G presents, according to many authors, as an ultra-fast and an ultra-low latency internet, fundamental for remote surgery because save lives, okay? So, again, our conceptual background is the technological innovation systems, a conjunction of actors, public and private organizations, networks, and technologies which compose a system in a metaphor perspective from engineering with function and dynamics. Why a metaphoric perspective? Because we are more attentive to the quality, to the concepts of these functions and dynamics, to the qualitative perspective, not in the quantitative perspective. Even though my approach and my results are based on bibliometrics. So, according to Hackert, the main author of the technological innovation systems, technological innovation system in technological innovation system terms, I'm sorry, it is possible to direct the speed and intensity of innovation, proposing some indicators of the innovation policies according to a specific technological systems, whatever it is. In this paper, we are working with two technological systems: the telecommunications domain, 5G and 6G 5G and 6G technological system, and healthcare technological system in case of the remote surgery. So the problem of context is in TIS perspective, technological innovation systems perspective. According to many authors, the crucial fragility of the technological innovation systems conceptual background is the problem of the geographical context, because it is a macroeconomic perspective. So we can't talk about the some mesosphere and microspheres of analysis. Okay. But some authors, some part of the literature, try to resolve this problem, thinking the TIS in regional and national perspectives, but not always in a multi-level perspective. Again, I'm sorry. Beans and Truffer and Bergek and colleagues tried to comprehend these problems of the contexts in technological innovation systems, especially in connection to decision-making and political perspectives in a policy mix approach. So we have tried to do something like that in our paper. Our methods is very simple, because we have 7 functions of this technological innovation system. So we work with the knowledge functions, which is knowledge production and knowledge diffusion, calculated by publications and patents, and publications and patents collaboration. But when we talk about function 2 and function 3, we can have some spoilers or some highlights about function 5. Function market formation, entrepreneurial activities, function 1, and research orientation, function 4, of course, because we need to have orientation in our research, which is bibliometrics in quantitative and qualitative approach, and something about research mobilization, because we are talking about the financial organizations, okay, that will funding the researches. Research and development has been established as a cornerstone of innovation, diffusion via channels of knowledge and technology transfer encompassing principally publications and patents. These endeavors have amplified the possibilities of research becoming an accepted application in the marketing. Nevertheless, recently has been a long journey for technologies to gain reliability in the market, which means that we are always talking about market formation. Okay, we're always talking about function 5, so we are not working just with function 2 and function 3. According to this perspective, just let me put this here. We are working with the international level and national level, and this approach can be applied to any geographical context because we can work with national TAS, for example, to Germany, to Brazil, to Spanish, to Finland, in any way, any kind of case study case. So at international level, we are working with the worldwide perspective, in a macroeconomic perspective. In national TIS, we are working with Germany, okay? Because Germany is a very diversified market, which has many enterprises such as Huawei, Ericsson, Nokia, and Science Push and Demand Pull in the same time. Okay, so this will guide us to talk about the technological change on technology transfer and spillover here. Okay, so we can, but we are talking about knowledge function, so we can talk about spillover also. Just a second. So this is my working formulas for publications and patents. That's it. So some results here at international TIS and national TIS in Germany. We don't have too much papers and too much patents here because it is a conjunction of technological systems, it's an interplay of technological systems, so we are reducing the sample. Even though this is a very important demonstrations of raw data on publications and patents resulting of 5G, 6G and remote surgery, a wonderful application. So sample one, scientific indicators, which is publications at international and national levels. Why I'm talking about international and national levels? Because it is natural to us appear Germany in our sample, okay? I will show how. So now we have a cloud here of bibliometrics terms in terms of keywords on 5G, 6G and remote surgery that I make a zoom here to understand the cloud. So we focus on the cloud of surgery, and we can see here robotics. We can see minimally invasive surgical procedure, which is remote surgery. We can see many words here: quality of service, network security, network architecture, future research directions, which can be 6G networks perhaps or not, or something like that. Applications, research scheduling, remote control, tactile internet with which Tartarian and colleagues will work on this very well in their article in 2022. So here I have by country. We have a map here of publications by country, and what I want to make attention for you, ask your attention, is because before 2021 the United Kingdom was the node of the relations between China and the United States. There wasn't a relation between China and the United States, but the United Kingdom made this connection, okay? So after that they denied the Huawei technologies. And then here at international level appeared everything about Germany, okay? So appeared by organizations, Department of Surgery in Killington, which is in Germany. I will show the map. We have Huawei Technologies in Düsseldorf, and we have some departments of Department of Surgery researching in probably in Germany, which can be Nokia, Ericsson, or something like that. So innovation indicators for patents, investment trend for key players. You can see the most part of organizations here, public and private, from China, but you have also Qualcomm, you have also Samsung Electronics, and etc. Here, this graphic for me is very special because it is a count of non-self-forward citations by assignee indicator. So we can see Huawei, Peking University in Hunan, Provincial People Hospital, in the first places of non-self-forward citations by assignee indicators. These assignee indicators. But on the other hand, Orbit Insight, we use the Orbit Intelligence and Orbit Insight to make the patents research. And we have HHS here in the United States and many other institutions, organizations, public and private, from the USA. So we have University of Southern California, University of Chicago, USA Department, and of course the Orbit Insight is focused on European USA direction, but they have the most part of patents. So China and the United States is the one of the biggest, of course, but I'm proving this here, okay? So at national level, and I arrive in the end, Germany, okay?
Marina, the time 10 minutes is over.
I'm sorry.
No, the time 10 minutes is already more than
Oh,
10
okay.
minutes.
Just in the last slide, okay?
Okay.
Okay, thank you very much. So we can see here many enterprises from Germany. We can see killing in the map. These enterprises in these public institutions in Germany are distributed in the map that we composed. We can see Düsseldorf and Killington here in collaboration. In the other institution, we don't know what is this because it doesn't appear, and some clusters of patents and family patents in Germany. Some discussions and conclusions. I won't enter very well in this because I already passed my time, but the literature says we are in nascent GIS stage, which is not truth because we have a solid market penetration through soft powers, according to our data, according to Modix and Russian Author also. Public policies have to be connected to 5G and 6G in the same time because it requires a forward-looking observations about 6G, including and national level cooperation with NISA, European Union, OECD, and also with China. That's it. Thank you very much. And
That's brilliant. Thank you so much, Marina. I appreciate that. Really appreciate that. Now, moving on to the next speaker, let me introduce Hirofumi Hoki from Tokyo, Japan, to present on generative AI and intellectual property rights by final design. Over to you.
Hi, thank you so much, Ganesh. Let me share my slide. Can you see my slide? Okay.
Yes, sir.
Okay, thank you. So, hi everyone. My name is Hiro from Final Aim. I'm handling sales and human resources and finance, and actually I'm based in Tokyo currently. So, it's a great honor to have this opportunity to present you all. So, let's get started. Final Aim is a startup based in US and Japan, aiming to solve the intellectual property issues that arise with the use of generative AI. Let's say, think about product as like GitHub for designers. Now, let me introduce our two founders. Our CEO, Masa, is a serial entrepreneur with 2 years experience in Japan and Singapore. Recently, he led an AI and 3D printing startups as a COO, successfully driving an M&A with a major listed company in Japan. Also, our CDO, Chief Design Officer, Yasu, is a professional in the industrial design area. And he also contributed to M&A efforts alongside Masa. Actually, these two have worked together for a long time at their previous jobs. So, needless to say, their teamwork is very seamless, So besides them, our team includes a serial entrepreneur from Google and Adobe present in APAC also, and a US lawyer with deep knowledge in startups interaction probably. And then as for me, I worked at venture capital, one of the biggest firm in Japan before joining here. So next one is, this slide shows our credentials. Well, Final Aim was selected by Barclays Skydeck as the most likely become the next unicorn. We've also been chosen for the innovation showcase at the Stanford University, and we also have an API collaboration with Autodesk, and have been selected by Microsoft as Microsoft for Startups. So Final Aim provides like GitHub for designers. Our customers are companies that want to use a Gen AI, especially in their design departments. Actually, they face challenges in design and IP management with Gen AI, so causing hesitation in adoption. I mean, the problem we're solving is related to intellectual property rights and the data management costs. As you know, the Gen AI boom is not slowing down, and but along with the boom, kind of big issues are emerging. For instance, when design department tries to use the Gen AI for designs, intellectual property rights become a problem. It's like it's almost impossible to tell just from the output whether the design was created by Gen AI or human. You know what I mean? So simply put, we believe that using Gen AI and the associated risks and IPs and copyright issues will only increase. Basically, our product has three main features. So, first of all, we are supervised by top lawyers in both Japan and the US. This helps prevent issues like such as determining which company owns the data and copyright. So second one is ownership and sharings, very clear and strict, very strict. You can immediately identify when and who created the data and which contracts linked to. So lastly, protecting IP requires proper management of design data and processes and contracts. I mean, we manage this data with a smart contract, ensuring the authenticity and providing a UI UX that allows for immediate verification. So let me introduce our use case. I will say that we've already implemented our solution with Yamaha Motor, a major manufacturing company in Japan. So they needed to develop a novel EV using Gen AI and with our platform. So then they are able to mitigate IP risks and collaborate on mobility development at a nearly twice the speed of the traditional methods. It's a big deal, right? So next slide is regarding to business model. Our business model is very simple. As you see, we receive a monthly fee from the enterprise side, and if customization is required, we charge a customization fee accordingly. So lastly, let's talk about traction. In approximately 6 months, data registered in final design has grown by about 350%. I have a feeling that the need to manage IP risks associated with the Gen AI is rapidly growing globally. Okay, so we are scaling quickly to meet this huge demand now. So I would say that even though we are seed stage startups, we've already secured the partnerships and integrations with some of the world's leading manufacturing software companies. Like including Autodesk's, Sony and Panasonic or something like that. So if you're interested, please reach out me. So that's my pitch. Thanks for listening.
Oh, that was so quick, Oki-san. Thank you so much. I appreciate that. Now, let me introduce the next speaker, Umair Hafiz from SAR, Bahrain, to present on cloud migration strategy and application to IT and telco workloads. Over to you.
Thank you, Ganesh. I'll share my screen. Okay, great. Hi, everyone. My name is Umair Hafiz. I work as a network architect at BNet, a company based in Middle East, Bahrain. I have 15 years of experience in telecom transport networks, where I have been dedicated in designing and deploying network strategies to meet the increasing capacity needs. I'm particularly focused on the challenges and the opportunities that are presented to us by 5G network rollouts. Today, I'll talk about how cloud computing is transforming IT and telco landscapes. My focus will be on the critical role of 5G transport networks and the fiber optic technologies. These are the topics that I'll be covering in my slides today. What is cloud? Challenges to the telecom cloud adoption, the migration strategies, the role of the 5G transport network, and the cutting edge fiber optic technologies. So what is cloud? Cloud revolution is sweeping across the industries. Why it is required, as it depicted in this graph, a research by President Research, telecom cloud market size will reach to 131 billion by 2032, which is huge. Businesses are realizing significant benefits from cloud adoption, including cost saving through the reduced infrastructure expenses, increased scalability to meet fluctuating demands of the industry, agility to respond to changing market dynamics, and lastly, the ability to foster innovation through the use of the cloud-based services. What is telecom cloud? A telco cloud is simply a highly resilient and flexible network architecture that combines basic features of traditional networks and cloud technology to make communication faster and more reliable. The key components of the telecom cloud are as follows, starting with software-defined infrastructure, SDI, which lets manage the network with software instead of relying on physical hardware configurations. Network function virtualization, NFV basically allows to separate the network functions from the hardware they run on. And then cloud native technology, excuse me, which uses same principles as cloud-based applications to bring flexibility and scalability to the network resources, which makes it easier to handle large amounts of data and the changing demands. Automation and orchestration come along together, Automation lets computers handle the repetitive tasks, and orchestration basically ensures all the different parts of the network work together smoothly. And lastly, the main key component, service assurance, which continuously monitors and manages the network to make sure everything is running um, smoothly and the customers are getting the best possible services they requested for. And by combining all these elements, a cloud, telecom cloud can help create an agile and efficient network. Moving on to the next slide. So challenges of the cloud adoption. In general, telecom industry has a reputation of being slow when it comes to any new adoption, and same went with the cloud adoption. And I think that the four of the main key challenges that they faced were traditional mindset, IT related obstacles, cybersecurity issues, and skill gap. What I mean by traditional mindset is that traditional telcos resisted cloud migration, fearing the data loss and disruption. IT-related issues because they struggled to integrate the legacy services with the new application. And solution here is to modernize applications to cloud-native platforms. Cybersecurity concerns, cloud adoption excites the telcos, but cybersecurity concerns arise. But these concerns are can be mitigated through real-time threat monitoring and proactive solutions to keep the cloud journey safe. Lastly, it's the skill gap. Telecom struggle to find skilled tech talent for the cloud adoption, especially in this competitive market. My next slide is about building a successful cloud migration strategy. I think that developing a well-defined cloud migration strategy is very crucial. The key phases that are involved in developing a cloud migration strategy are starting with the assessment phase. The assessment involves identifying the workloads that are most beneficial to migrate to the cloud, considering factors like technical feasibility, business criticality, and of course the cost saving potential that it can bring to the telcos. During the planning phase, telcos need to determine the most suitable cloud model and the migration approach. They need to choose the most suitable cloud model like public, private, or hybrid that aligns to their specific needs. Security considerations are paramount. Telecoms must establish a robust security control and compliance measures in the cloud environment. And once the workloads are migrated, the ongoing management is very essential and crucial to optimize the cloud costs, ensure that the cloud is secure, and to continuously improve the migration strategy based on the experience and the lesson learned. 5G transport networks, which are backbone of any cloud. 5G transport networks are very critical. Like cell towers provide the infrastructure for mobile connectivity. 5G transport networks are high bandwidth requirement to handle the massive data volumes which are associated with the cloud workloads. Its ultra low latency capabilities are essential for the real-time application and services that are increasingly moving to the cloud. And lastly, the network slicing capability, it allows telcos to create dedicated and secure cloud connections for their specific services and ensuring the optimal performance and the quality experience that they they confirm to their customers. As the technology keeps advancing, cloud-native platforms are becoming a new standard for the businesses worldwide. One of the Gartner's predictions shows that over 95% of the digital workload is expected to be on the cloud by 2025, up from just 30% in 2021. These are some of the advanced technologies that are that provide the foundation for the cloud migration in telcos. Advanced fiber optical technologies includes SRv6 and DWDM, which is dense wave division multiplexing. Due to the time limitation, I won't go to the details of these for now. This is my concluding slide. Telecom industry is at crossroads, and those who embrace the transformative power of the telecom cloud will be well positioned for the success in the coming years. One of the examples that I can quote here is about Vodafone's cloud migration. Vodafone moved their 50% of the IT applications to public cloud, which reduced their IT operating cost by 25% and improved their service deployment by 40%. Some of the future trends that are 5G related technologies will enable new cloud capabilities. Even the 6G networks will enable more distributed cloud architecture. And I think AI-driven migration and optimization tools will be very helpful for these cloud migrations. So this is the end of my slide. And thank you, Ganesh, for your effort and bringing all the industry experts in this platform. And thank you all for your time.
Great stuff. Thank you so much, Umair Hafiz. Really appreciate it. Now, let me introduce our last speaker, S. Mohib Hassan from Toronto, Canada, to present on IoT and industrial 5G applications. Over to you, Mohib.
Hi, everyone. Hi, Ganesh. Thank you for handing it over to me. I'm just going to share my screen. Let me know if that's good. Can you guys see my screen?
Yes, sir.
Okay, and it's in full screen, right? Just making sure.
Yes.
Perfect. Sounds good. Hi everyone, my name is Syed Mohib Hassan, and I've been involved in the IoT industry for almost past 8 years or so. Recently, I've been working in the Canadian telecom sector, and prior to that, I had been doing application engineering for the mobile machinery industry. As you can probably guess, I'll be talking about the IoT and the IoT technology and its applications, and also covering how does it intersect with the latest mobile network generation, which is 5G. Okay, so in terms of the agenda for today's brief talk, we'll start by diving into IoT, what it means, some of the key value propositions, the core IoT connectivity, what kind of connectivity solution would be the right fit for your IoT deployment. And then we'll segue into the the 5G applications and see how does it relate to IoT, what are the benefits of 5G that we are leveraging for IoT. And finally, we'll wrap it up with some key takeaways. Primarily, IoT stands for Internet of Things, as we all probably know. And it's basically a network of various devices that are communicating with each other or at a hub. And that is what the term things refer to. Though it may seem a bit vague, but I think it's a perfect term because as we are moving forward, we are continuously adding more and more devices on the network that we conventionally had not thought of, being connected to the network. And now industrial IoT or IIoT, as you can guess, refers to the industrial usage of the IoT technology, which can include manufacturing plants with robots, PLCs, HMIs, monitoring systems, etc. Initially, IoT had been used primarily for sensing and monitoring. However, as we are progressing and we're working towards the revolution of Industry 4.0, and working more towards the more complex solutions, we are moving towards control and automate or control and automation through IoT. And just to give you a sense of the scale of the deployment of IoT devices all around the world, the projection is about of 75 billion connected devices worldwide by 2025. So that should give you some idea on how big it is right now, and also growing at a very steady pace. So that's about 10 devices per person on this planet. And now looking at some key value propositions of IoT. So there are various value propositions that IoT offers that can differ from type of industries and use cases, but primarily all of those four value propositions and benefits are driven by these four main value propositions that I've categorized here. So data collection, I believe, is the core benefit of IoT, as that is what enables all other use cases for IoT. So this allows you to monitor and sense any parameter remotely, further enabling you to analyze the data and make decisions based on that. Now, automation is another benefit of IoT that enables you to take action based on the data that you have collected. It can be actions such as triggering alerts, events, switching on off controls, or simply just logging critical events. Predictive maintenance is a data-driven, proactive approach that IoT enables for us that we did not have earlier. And based on the collected data over a certain period of time, predictive maintenance plays a significant role in reducing financial losses that can occur because of equipment failure or any sort of issue that occurs due to lack of maintenance. And finally, the safety value proposition is basically, it applies to all of the industry verticals overall. And you're focusing on parameters such as health vitals or fall detection and heartbeat, etc. I know we're short on time, so I'll quickly go over it. But when you're looking for the right connectivity solution for your IoT deployment, you have to keep in mind that there are certain trade-offs that you have to consider. So for example, if you look towards figure 1 over here, having or using a short-range solution, for example, or connectivity allows you to have an energy efficient solution. However, and also a higher data bandwidth. However, you're compromising on the range of the coverage. Similarly, on the private network side, on the commercial side of things, if we look at having a higher quality of service and security, and also having a lower cost, then private networks are a good solution. Ganesh, if you can just give me a time check. Sorry, I think I had my slide running for a bit longer, so I'm not sure.
You have another 3 minutes.
Okay, perfect. Sounds good. And the private network piece, I just want to highlight one point over here. It is a low-cost solution or fairly reasonable or cost-friendly if it's a Wi-Fi-based solution. However, as you move towards having a cellular-based or a 4G/5G-based private network, the cost increase is drastically. However, you can cover a lot more critical and complex use cases, and we'll look into that in a second. I'll just in the interest of time, I'll skip this slide, but basically gives you an idea on an example of use cases, what kind of technical requirements and commercial requirements will lead you to selecting or opting for connectivity, cellular or low power or low power high wide range or wide area coverage. 5G and its applications. So there are three main categories. that we can divide these 5G applications into. So ultra reliable, low latency communication use cases that are mostly fit for an industrial environment. We've got the massive machine type communication. That is where the IoT comes into play. As we saw earlier, that we are projecting about 75 billion devices to be connected on the network by next year, 2025, and eventually it will grow further on exponentially. So that will require a network that can support such large amount of data and also a number of devices. And the third category is the enhanced mobile broadband that offers you high speed and enhanced broadband compared to the previous generations. I've shown a few examples or key applications that leverage these capabilities of the 5G technology. One thing that you can see that is very common over here is like low latency and high reliability. That kind of is very useful in automotive sector, especially autonomous driving, industrial automation, where you are trying to achieve precision and trying to control complex functions, and also teleoperating. So it can be through Land Rovers or drones, but you're not just only monitoring your sites, but you're also controlling them. So sort of a command and control play over there. And finally, just a quick key takeaways. So we can definitely agree that the number of IoT use cases and devices connecting to the networks is increasing globally as we move from sense and monitor towards control and automate. And 5G will support this exponential growth for IoT devices, as well as numerous critical industrial applications, improving overall organizational efficiencies and creating a safer and a better workplace environment. Thank you. And please feel free to reach out if you would like to on my email, and also you can join me, connect with me on LinkedIn. Thank you.
That was brilliant. Thank you, Mohib Hassan. I appreciate that. That was great. So let's have a quick 10 minutes or so Q&A session among the speakers to discuss about telcos slowly dying. Is the spectrum race dead? And what are the emerging 5G or any use cases that have potential to disrupt the telecom industry, particularly the mobile network operators? Anyone wants to start? I just give the privilege to anyone to start.
Well, I can take it if it's not a problem. So thanks, Ganesh. I think let's say I'll address on the first questions that you raised. Are telcos slowly dying? I think with tech being evolved day by day, and then just now, all the panelists who are or the speakers who are sharing how things are moving on with 5G. I don't think it's going to be brighter future for the telco, but they need to capitalize on it, and then they need to actually start to be more modern thinking or forward thinking. In this case, they cannot be stopping at the current old thoughts or traditional thinking that some of one of the speaker was actually sharing as well. So that thought they will actually out of contention in this case. But by moving together with these technologies, working closer with partners, developers, and company alike in the market, that will definitely help them to actually quicker or exponentially grow together with the market. And I think this is a key for their success. They can't be doing everything by themselves. And of course, together, the government and also some of these associations like GSMA, they play a pivotal role in ensuring that the growth of this industry, and then also the incentive that the government or the relevant, let's say, regulator can provide to actually drive more awareness or change of mindset of the market in adopting all this new technology. And definitely telco can actually have an exponential growth with all this in place.
Thank you, JK.
Ganesh, just to add to what June just mentioned. So I think I don't know if I would agree with the statement if telcos are dying. However, I think that the key to kind of providing value to the market, I think it's very important for telcos to do the right partnerships. So conventionally, telcos have relied on just the network or the connectivity solutions, right? Now, with technologies like IoT, we are seeing that a lot of telcos are playing in that market as well. They are kind of reselling the solution. They're partnering with vendors and OEMs to offer a holistic solution to their customers. So, because at the end of the day, the customer primarily does not care if it's 5G or 4G or Wi-Fi. What they are looking for is a solution to their problem. And if the telcos take that approach, that hey, we are addressing these issues within your industry vertical, that keeps them in business. That's what I think.
Thank you, Mohit. Anyone wants to take it up?
I think I have a position. Of course, telcos are very important to the market in the market, and they cooperate a lot. Telefonica is one of the biggest enterprises which cooperate with all over the world. Many organizations, public and private. But what's the role of telcos in the market if there is not? If they can, they should make good better prices for the consumers, and they do not, and they do they don't bring us. I mean, in my position of consumer, as final consumer, they don't bring us a good products. They just share the products from the suppliers, and I don't know what I'm sorry, I don't know what the role of telcos in the market. Truly, I think they could coordinate all the collaborations and the researchers, but it is a good question.
Yes, Ganesh, I would like to add something that is currently happening, okay? But I think that we need to put focus on, and it depends on the area of the world that we speak about, okay? But it's consolidation. When you analyze, for example, what is happening in Europe, the number of let's call it tier one MNOs that we have here, it's huge. Doesn't make sense. Okay, and if you compare, for example, with the US market, and you analyze key indicators like ARPU, like profitability, and so on, you have some answers. And consolidation is not only regarding to business, that as I mentioned before, we are starting to work on that. It's also regarding to infrastructure. Doesn't make sense to multiply the MNOs infrastructure by the number of MNOs. It's network sharing is a reality from last decade, but we need to put the focus there. Some of our colleagues spoke about cloud. Cloud could help to do that, but also in the passive infrastructure, it is critical. If we don't do that, we cannot compete. And for me, that is something that I think that is in the board of all the MNOs, but we need to adapt to the reality quicker. That's my point.
I realized that I haven't got the real updated numbers of this year. As for in August, what are the number of mobile network operators who are still having the 5G standalone? Because the last month I got to know it was still about 40 plus, which was no different compared to last year. So most of the mobile network operators are still in non-standalone, depending on the 4G core network platform, so that to cut their cost and everything. So the question is, the industry has been saying, the GSM has been saying that this year we could see a lot of developments of more mobile network operators will migrate to standalone, which is not in that case as for in August. So so it's still waiting case, right? Are they waiting for 6G, or because I know 6G is too far away, because the cost for 5G standalone is quite huge, right? To build the core network is quite huge. So the APIs that is really picking up. 5G private network is really picking up. A lot of them feel much more easier to move on with the 5G private network, less complexity. But to build the end-to-end 5G standalone with all these innovations in network slicing and all that stuff, there's a lot of complexities involved, and some or quite a number of mobile network operators doesn't want to involve in those complexities and challenges in those deployments. Yeah, anyone wants to add on?
Yeah, so I think telcos are not dying, rather they are evolving. While it's true that industry is undergoing significant transformation, but it's more accurate to say that telcos are evolving to adapt to the changing technological landscape. That's my view.
But regarding what Kaneshwaran said, who will give us the 5G standalone with good prices? I don't know if it will be the telcos or the MNOs.
Maybe the delta is not who will give us the best price, but who will present the benefit, the economic benefit, and at the same time see the balance between cost and benefit. What I mean is that, take for example, as a domain industry 5, industry 4 or 5. Industry 5 means automation. Means that the efficiency and the sustainability will skyrocket. But in order to have industry 5, you need robotics, you need self-driving vehicles, you need fully autonomous systems with AI at the edge and the cloud. And all of this, you need to be a slice that will be an end-to-end 5G network. Am I right? If you look at the specifications, you need massive connectivity and everything. So if you need something like this, you need to think it from the business part. I believe that the businessman and maybe all the people that comes from SMEs and industry can help on this. What they look is if I do this evolution, how quickly I will surpass the critical point where the budget that I gave will become equal with the benefit, and then I will start to have gains. And this is something that I don't know if we have already specified as a wireless world.
Anyone wants to add? Dr. Victor, do you have anything to say?
Yeah, no, I process everything to relate every opinion. So in my mind is more focused on I think another space. So I'm more focused to reach more coverage, to increase the coverage with the network. Not from point of view of the MNO, so more point of view of the operator to reach more services. So in my experience, so I'm more focused on the satellite network to my related to my presentation. I think this a new opportunity, and we have a new market now. The satellite or the space operator, the space market is a good opportunity now to revolution the sector or the application and the different service. So now we are more focused on to increase the coverage, in not related to the capability of the feature of different services.
So when it comes to the satellite space, I believe the direct-to-device is another new opportunity to the uncovered areas geographically. Yeah, I think in the next 3 years, from 2024 to 2027, the GSOA together with the 3GPP has to work together to complement each other in terms of the convergence of the mobile device and the satellite. It has been many years or decades, both parties will never talk each other because they want to protect the spectrum. And so now we can see that they don't have any other choice because they have to work together to protect both the satellite service providers' future and also the mobile network operators' future as well. Because this is another opportunity opening for the MNOs to look the area where the rural connectivity, because like solar panels might not be so relevant. Satellite will be much more better for those rural coverage areas as well. So I think this is a great opportunity for telcos as well.
Yeah, exactly. I totally agree. And also, you mentioned the direct connection to the device. So that is very important because we get the small satellite. For example, this is a first revolution in a new area space, but also the direct connect now we are working on that. So it is very important. We get the reduce of the size of satellite, but now we have to get the reduce of the devices for the satellite. So to get the directly connection. So and it's so far the all satellite or all space industry are working alone, and this is an opportunity to work together with another industry. Yeah, this is I totally agree.
I'd like to say a little thing more, just to clarify my position. I totally agree with you. They have to cooperate and collaborate in terms of telecommunications, R&D, and all other such things. But we are according to GSA reports, we are in 5G advanced in many countries, such as continents such as Europe, United States, China, including Brazil. And this is because of MNOs and suppliers together, working together. So I think this is very important also.
So basically, the partnership of the chip owners, the mobile operators, the whole ecosystem players should work together rather than isolated each other on the geopolitical tensions should be avoided as much as possible.
Yes, in the technological systems or ecosystems, the same term. Just works if all the actors join together, act together and in coordination and everything that. So I think this is very important.
I think only the technology researchers and innovators, technology lovers are the ones who's going to unite the world together rather than the political leaders who wants to isolate due to the geopolitical strength. So I think this should be avoided. I think we need to bring the world together. Anyone wants to have last say here?
And also, sorry, related to the working together, the cooperation, I think it's very important. One thing I didn't mention it is the relation point. We didn't mention in any presentation, or we didn't consider for example, for the satellite, is very important. We to focus on different countries, but the regulation, different country, different technology, different industry. So now the regulation point is very important and we have to consider. So we have a lot of work to do for the regulation aspect for a new technology or new future of the new ecosystem network.
Great. So yes, thank you so much. I really appreciate all the speakers for today's conference. Thank you so much to the audience. Please do subscribe our YouTube channel by clicking the subscribe button on our YouTube. This video will be uploaded in the YouTube in the next couple of hours, and we will notify to all the speakers, and we'll start promote this video for the next 1 month. We will feature each speakers on our Global 5G Evolution LinkedIn page. I will communicate in a separate email to get some summary outline, about 8 to 10 lines from each of the speakers, and then we'll blast for the next 1 month, so that will give a much more better coverage for today's event. Thank you so much. I'm really grateful to all of you. Really appreciate it. Have a nice day. Till then, take care.
Thanks, everyone. Thank you, Ganesh.
Thank
Thank
you.
you.
Thank you very
Thank
much, and congratulations for all.
Thank you.
Congratulations.
You.
Goodbye.
Bye.
Bye.